Hello, and welcome to lesson number 2 from New Jersey. Hi, fellow high school students. This is on types of mirrors. So there's 3 types of mirrors. When you usually think about a mirror, or looking at yourself in the mirror, you think of about a flat or plane mirror. Now usually, one side is reflective and one side isn't. If you look at the back of the mirror, it doesn't make a reflection. So often we put a little squiggly thing on the back, just to know which side is the front and which side is the back. So here you are in front of the mirror. La, la, la. Great artistic skill. Let's give him hair. Or a crown, I'm not really sure which. Sorry. Gotta have face. Okay, so here you are in front of the mirror. Now lots of people think that the image isn't on the surface of the mirror. But if you take a step closer to the mirror, or take a step further back, your image also takes a step forward or takes a step back. The image is actually behind the mirror. It's not really there. If you put a film there, it won't make an impression. But it looks like your face and your body, it's supposed to be the same size, but with stick figures it's sort of hard to do, is behind the mirror. And another thing that happens with mirrors, and it's more obvious with words than with pictures, if you look at the reflection of words, everything left turns right. It turns backwards. And the reason this happens is what changes is front and back. You're facing the mirror. The image is facing you. So when front changes to back, left changes to right. And that's why all your letters get mixed up. But if you go to Crazy Fun House, or if you just look in the side view of a car, you can have curved mirrors. And if it's curved this way, it's like it's caved in. And this is called a concave mirror. Just like the lenses that are caved in are called concave lenses. And if it sticks out in the middle, it's called a stick-out mirror. No, a convex mirror. Convex mirror. I like to think it's vexing to stick out in the middle. But that only works if you remember that vexing means to make you unhappy. If you don't remember that, then it doesn't help. But concave is caving in, and convexing is the other one. Now let's talk a little bit about what happens with horizontal light. With a flat plane mirror, it just goes and bounces straight back. With a concave mirror, if it's in the middle, that's where it's flat, so it bounces right back. So it goes in to the center and then bounces right back. If you hit on the top, you hear it, see, now here the mirror is pointing down, so the light gets reflected down. If you start at the bottom, the light gets reflected up. All this light gets reflected to a focal point. So that thing is a positive focal point. And actually I read something recently about making a low-tech stove for used in poor countries, where they just got basically a big cylindrical, spherical mirror, and you put in the sun, you put your food in the middle, and it heats up, which is great because it doesn't use fuel, it doesn't use great chemicals. The big problem with it, it's not sunny, you don't get warm food. Okay, so this is the positive focal point right there. So where all the light really focuses. Focal point greater than 0. Convex mirror, what happens with that? Well, once again, if it hits the middle, it bounces straight back. If it hits on the top, you can see that it's like a mirror pointing up. So it makes it reflect going up. And if it's on the bottom, it makes it reflect going down. This wasn't really the middle. It was supposed to be the middle, but, you know. So it looks like it's all scattering from an imaginary virtual focal point right here. So in this one it has a real focal point, and this one has imaginary. Very important. Mirrors are opposite lenses. Mirrors, the light reflects. Lenses, the light refracts, which means bends. Which means also the rules are opposite in terms of what's real and what's virtual. With mirrors, the concave mirror is real. Real focal point. It really focuses. With lenses, it's the convex that's real. And then the reverse is true. If you have a convex mirror, you get a virtual focal point, f less than 0. If you have a concave lens, you have a focal point less than 0. So the next lesson will be on how to write and draw the ray diagrams to get your images. Okay, that's the end. Bye.